vector group, vector groups. Okay, we'll do vector group. Somebody is trying here. Okay, here joined. Now vector group. So far we have discussed very important thing. Just some review of the last class we can do here to understand it is again. Some point can be missing, then you can recall it again. So first of all, we have said that three-phase number one EMFs are used for vector group. But not applied voltage, but not the we say that not the source or not not the EMF, that means E, they are used, but not the voltage. Yes, as G. Okay, you have to understand what is E and V basically. Anybody know the difference between E and V? Just tell me if you know that.
Sir, V is the applied voltage, E is the induced voltage.
Okay. So actually V basically equal to IR or IZ. Okay. So this is called V. That's the by the Ohm's law. Okay. What is coming, that's called the V. Got it? And so but E is the E is actually generated. So that's the difference between E and V. So the vector group always are denoted with the help of the E or EMF. And here by phasor. Here by three-phase EMF phasors in RMS. Phasor can be represented in feet also, but here we will use the in RMS. Number two, we have discussed that very important point you have to remember. If you mistake, then everything will be cascading. Mistakes will be going on. So this thing should be strictly maintained. What do you want to say that? Number two is that hold that. Primary or secondary of a transformer are not considered. Rather, we use high voltage or low voltage. Okay, notation. So whatever may be the primary, whatever may be the secondary. So which side is low, which side is high, that also only considered. Okay, not the primary or secondary is considered. So anyone may be primary, anyone may be secondary. Number three is that in a reference. Okay? What is the reference? A reference is that HV, high voltage. Okay? And it will be on always in a clock at 12. It will be 11, it will be 1. So reference will be always at 12 and that will be high voltage. Am I clear? Hello. Always you have to refer and that will be HV and it is a phase EMF, you can say that. Not the line. You cannot refer line, phase. Whether it is a actual phase is coming, then you have to refer actual phase. If it not available, then you have to consider the virtual phase. Okay. So actual phase generally available into the star connection, and another different connection is are also there that will be discussed later. And the delta connection, phase voltage, actual phase voltage are not available, so there we have to refer to the uh, actual one. So at 12, high voltage will be always considered. So that means it may be primary winding voltage also, or it may be secondary voltage also. It depends on whether it is step up or step down. If it is a step up, then high voltage will be the secondary side. If it is a step down, then high voltage will be primary side. So, but in case of the vector group, you have to consider only high voltage. You have to forget about the primary and secondary. So thereby we see that in a delta connection, one important thing we have considered, and now the observation for a now case. So case one for we have said that it is a YG11. So in that case, you have to draw suppose YG11 vector group. So suppose you have to do YG. So how to draw this? Last class we have discussed. Again, you can go for it. So first we will maintain. So here it is a capital letter. So that means it is HV. It is a small letter. That means it is LV. It is 11. It is at LV. Okay, here it will be at LV. LV at 11. And all are will be into the phase voltage. Yes. Yes. So this is the consideration. So what you have told that high voltage will be at 12. So thereby, so if you want to represent whatever may be the phase, then one phase must be like this. So this will be suppose one phase. So suppose this is called the A, okay, a phase. And obviously then it will be capital letter A means it is a high voltage. And what will be the 11? So 11 means here in a clock it is at 12. So 11 will be somewhere here. So then low voltage will be like this. So this will be the low voltage. So this will be the corresponding voltage. It should not be EB or EC. Then it will be EA, and EA here small letter means it is a low voltage. So you see that notation, capital letter is high voltage and small letter is delta, low voltage, and 11 obviously will be low voltage because high voltage is considered as reference. Now in this case, this is the basic idea for corresponding phase. So that means A phase high voltage will be along 12, then A phase of the low voltage so will be and all will be phase voltage. So all will be in the phase voltage. So then what will be the other phase? Obviously Then other phase we can draw now the actual connection, then we can draw now actual connection, so that you can understand meaning of this. Okay. So actually we are going for this into the three-phase system. So in three-phase, obviously if we consider A phase is here, so that is called the A phase. Then obviously B phase and C phase will be like this. So it will be the B phase, it will be 120-degree lagging to that. So then it will be 120-degree lagging, it will be B phase, then it will be C phase. So it will be C. So that's the three phase, and that's our EMF. So E, all are E. Yeah, E. So I have not written E for all, but it is E. Then we know that the similar induced EMF of the primary and the secondary, whatever it may be, high voltage or low voltage, they are in the same phase already. We have reviewed the single phase transformer and found that that must be the same phase. So, but here the connection diagram will be 11. So thereby you can say that we have low voltage can be drawn here. So this will be then the uh, A. Okay. So here also it is E induced EMF. Okay. So here then it will be EAV. There it will be EAV. So induced EMF A phase in same phase, and the B phase will be you know that B phase are into the same direction, but it will be small letter, and then this C phase will be. That we have discussed in the auxiliary class. Then you see that these are the line voltage basically. These are called the line voltage. Line. And here also the line voltage is this. These are called the line voltage for a three-phase system. Now, as delta, phase voltage are not accessible, but you have to produce a virtual. So that will a virtual the phase voltage will be this. That the tips will be along this because it will start A. You cannot do a B like that or C like that. Okay. So you see that this is called the you can say that is a phase. This is called the FS. So now you can consider that the EA high voltage is this one and EA low voltage delta is this one 11. So that's why this group is called the YG11. So we have discussed this. Very importantly, we have discussed. So far we have discussed. Any confusion anywhere you can ask me. Whether you have any confusion or anywhere. So this is the fundamental part. So if you can do one thing, and if you successfully understand this matter, then you can develop all the connections by yourself. No problem. There will be no problem at all. So here we have understood that the connections. Now, what is the observation for start to Y to delta or start delta? Basically, it is called the start delta connection. It is called the basically the start delta connection. Okay. So, what is observation in a start delta? Anybody can say what is the observation in start delta? What is the actually problem in start delta? There is observation, there is a problem also. Can you say what is the problem? Hello. Anybody else? So I think they have got it. So here we say that in star delta there is 30-degree phase shift. Have you observed this? What is the
Yes,
problem
sir.
is there is a 30-degree phase shift. So what is that angle? This angle basically is becoming 30 degree. So this is called the 30 degree. This angle is basically 30-degree phase shift. It may be lagging, it may be leading. So what is here, lagging or leading in this
Leading.
y delta? So it is a connection plus 30-degree connection. Okay, so it is called the plus 30 group. So when you do the YD11, so that is called the plus 30 group. So that is a problem. When we do the star delta, then there is a phase shift. So this has become a very big problem when you do that, because mm, you can understand. So one transformer is finally has come to, suppose, a Mograhat. You know that Mograhat. It is a very big power grid. Mograhat, you know that, or it is giraffe. Not the Mograhat already considered. So what is giraffe? Giraffe. Do you know the position of the giraffe? It is away from Barashat on the national 34 road. So there is a big power grid. Okay. So a power grid is basically connecting all the power stations with the high voltage sources. So all the however, some suppose the one power station, Kolaghat, is sending some power at Jirat power grid, and the Maithon BBC also sending some, even the NTPC Farakka also sending. So different transformer is they are getting there. So now, if you by the way intermediate position, there will be lots of transformers star delta, star delta, star delta. So you will see that how much the phase shift is going on in between the transmission of the power. With the lots of transformers are used in between. So that's the problem, interconnection problem. So now you have to consider which connection you are basically. So first you have to determine, that is the importance of the vector group. So without determining the vector group, you cannot parallel them in the power grid. So that's the identification. So that's why this is called one YD group. So that is the importance. So phase shifting is going on. Similarly, suppose if you want to be YD one, then it will be how much? Minus 30. So it will be minus 30. In the last class, we have discussed how to do that. Again, we will go for that. Very simple. In the left hand side only, I will do the right hand side, because left hand side as it is. Oh, so left hand side as it is. So we can keep here the same thing. Okay. So this thing I can draw here. Same. Okay, but the side. So LV side is this, which is you can do that very successfully. You can do that. It will be the A, then it will be the B, then it will be the C. So here you see that this same A has tips here, so it has become the YD1. So that is the, again you see that the phase shift is 30 degree. So that is the main topic, YD1 and YD11. So similarly other connection also you can make it. Okay. Similarly reverse connection also you can make it. Okay. We can make the uh, so now suppose we want to y6. Can you do this connection? So this is a very important connection. So we want to do that YY6. So how to do that? So winding connection already I have discussed in the last class. Again I will do that again here. Parallelly we can draw the winding also. So this is if it is a winding. So we can draw the winding here. Okay. So for this we can draw the winding also. So but here winding is this tips arrow will be dot, okay, for everyone. So this will be for A, and this will be for B, and this will be for C. You have seen that. Now accordingly terminal will be marked. This will be A because here interconnection is there. This will be B, this will be C. So don't be confused which terminal is which one, okay. So that's the connection diagram. Similarly for here also you will find that if you want to do the connection for Y high voltage side, then the connection will be like this, and this is the connection diagram. Okay, so then it will be A, it will be B, it will be C, and the drop will be like this. These are called the polarity. Already I have explained relative polarity. So what should be the polarity of this two? So that's the connection diagram, and also phasor diagram you can do here. Already we have repeated the same thing, so that's why I am now going to draw. Now our task is to do this. You have to do the YY6. Can you do this YY6? Hello. What? How to? First you have to draw the YY6. How to draw the YY6? So for this, again we have to mark this again the phasor diagram. So now we have to mark the terminal. Okay. You can either you can make the dot or you can make the terminal. So whatever you want. So now better to make the terminal 1, 2, 1, 2, 1, 2, so that you can make here also it is 1, 2, here also it is 1, 2, it is 1, 2. So these are the terminals you can make 1 and 2. So as there are two terminals for the each winding of the three phases, so you can make it two terminals. Now the task is to make the YY6. How to do this? First of all, what is the 6? Okay, meaning of the 6. You can do that. So meaning of the YY6 means, so you can draw here. How is my pen? Okay, here. Yeah, YY6 in watch you can or a clock you can say that what is the meaning of the YY6. So if it is a 12, so the high voltage will be this one. Okay? This will be V. Then low voltage will be this one. This will be LV. So this is called YY6. Got it? So what is the significance of the YY6? So that's the point of the YY6. So how to make it? So for YY6, you have to make first we draw here again like this. So it will be A high voltage. So then that is 1 and 2, and then it will be the B, that is B. It will be 1 and 2. Then it will be C. It will be 1. It will be 2. Now what will be drawing of the YY6? Hello. How to make the YY6?
180-degree phase shift.
Huh?
180-degree phase shift.
Let's see. So before that we have to understand something. Okay. Okay, first we have to understand before going for that. Suppose a phasor is this. So this is suppose a phasor, any phasor. Suppose it is a ABC T phasor. T phasor. So if we draw it what is the angle? So D is equal to D angle 0 degree. So what does it mean basically in time scale? If we want to draw in time scale, what does it mean? How to draw it in omega t version? Hello. In time scale, what will be this? In omega t, it will be like this, sinusoidal. Okay. So this is basically this one. Now if it is a like this, what will be this? Suppose it is minus of d. What will be this? How to draw it in time scale? Hello. So it will be like this. It will be here. So now meaning of the YY6 is that we have to reverse the polarity. So what does it mean basically? It means if we apply this, suppose D as a source, so a load is here, okay? Suppose a D is here, okay? Now, what will be the current direction? Okay, if D is applied, what will be direction of the current through this? Can you say at T0 plus, ah, what will be the direction of the current? Hello, hello. So this will be the direction of the current. Now, if we apply another source is like this, minus of D at across the resistance, then what will be the direction of the current? So at T0 plus, direction of the current will be like this. So that's the difference between plus and minus, okay, or 12 and 6. So now you have to do this. So how to do this? How to do this? Now if we make it into secondary like this, okay. So this is the connection. That means star point is on the opposite side. This is called the star point. So star point will be on the arrowhead. Hello. So if we can do the star point at the arrowhead and the line will be like this. So then that will be the YY6. So got it. So how to do this into the connection diagram? So in connection diagram, so the high voltage will be like this as it is. Okay. See, uh, And the other side will be like this. A, B, and B. So that connection is called the Y6. Now I can say that you have understood what is the physical significance of the YY6. So this is also connection we can make using the concept YY6. Now the reverse connection also we can do. That means the uh, what will be the DD0, you know that, or YY0. This connection also we can have. So what is the YY0? It's very simple. So do it. So very simple. That is YY0 and DD0. Okay. So you have to do it. So however we can do that. Actually, in delta already I have told you. Suppose this is the connection is A. Okay. And this is the connection of B, and this is the connection of uh, C. So you can say that this is called the A. Okay. So this is called the DD0. Similarly for secondary also you can do same thing. Will be the low voltage will be there A. This will be the B. This will be the C. Okay. There also you see that the same phasor is there, so that connection is called DD0. So this is the connection of DD0. And correspondingly winding also you can make the connection of the winding. Now also you can do the another connection is called the DD6. Sorry. Suppose you want a DD6. Can you do that? Hello. Who are there? Or everybody has got some other
Yes,
idea?
sir, we can do it.
Okay. So you have to understand how to do this. Okay. So DD6 means I draw here. Okay. I think winding diagram is not I am doing repeating. Okay, winding diagram you can do winding diagram earlier I have shown, and winding diagram can be done only if you can do the phasor concept. Okay, if you do the phasor, then winding diagram is very easy. And in answer script also, don't try winding diagram first. Okay, winding diagram means this one. Okay, this one. This thing don't try first. First try the phasor, phasor concept. Then you accordingly draw the winding. So that will be very convenient and you can understand also. Otherwise, it is not possible. So for DD6, again we are going for the same notation. That is called it is A, and the it will be the B, okay, and it will be the C. Now it is the B, it is the C. What is the phase sequence? Can you say what is the phase sequence here? Okay, phase sequence. You have to maintain the phase sequence, otherwise everything will be indulged in. Okay, phase sequence you cannot change. What is the phase sequence here? Anybody can say that? What is the phase sequence of this delta?
180
Although it
degree.
is line voltage, you can see that in line
ACB.
voltage. No, ABC. Okay. Uh, ACB. Hello. Okay. Okay. You can draw it separately. Right? So if you draw here, so this will be A. Then this will be C. Then this will be okay. So obviously it will be the phase sequence. So, yeah, phase sequence is then ACB. Have you got it? How to find the phase sequence? So this is called the phase sequences ACB. You cannot change phase sequence. Or once you making connections, so that's not allowable. You can't change the phase sequence. So phase sequence you have to maintain. This thing you have to strictly follow. You cannot do randomly. So that's why phase sequence here is ACB. So now we have to do the DD6. So what you can do now? Okay, we can do it. So this is the catch here, okay? So this is A, this is C, this is the D, okay? So here are the lines are A, C phase line, sorry, C, it is B. So these are the three phase lines, okay? But here, three phase lines, when it is DD6, you see that this is the A, okay? This is the, sorry, B. This is the, and here we can say that it is the connection diagram. So now we can say that this is called DD6. Got it? I have not changed the, but the connection is earlier what you have done, earlier connection, you see that in earlier DD0, C positive has been connected with the D negative. Here you see that. Where is my phone? Here, C positive has been connected with the B negative. Now, we see that A positive here has been connected with the B negative. So this is the changing of the connection. Similarly, C negative has been connected with the A, and now here it is connected with C. So that's the connection diagram. Now how to do the connection? So connection is very complicated. So you have to do the connection, draw the again. You can draw the connection diagram very easily. So that it is called the B. It is called the A. So this is the A, and this is called the C. So this is C. So here also we have told that this will be the C. Sorry, this will be actually C. Yeah, this will be C. And this will be the B. This will be the A. Okay. So that's the connection diagram. So that is the main catch here. You can do the DD6. So there is a slight different connection DD6. So here also already YY6, DD6 connection DD0, YY0. Now YD. Now if we want to do DY connection, okay. So what will be then the pattern? Today I will concentrate on the connections because This will be actually coming into the exam. So dy, what will be the connection dy? We have not formulated any connection dy. So first dy means we have to do capital B. So that will be A, and then the suppose this will be A, and then this will be the B, then this will be the C. So now you have to connect these as a Y. So this is the terminal, or you can say this is A, this is terminal is called B, this is the terminal that is called C. You know that A, B, C connections. Now dy, how to connect these one as a like this. So it will be uh, A, then it will be B, then it will be C. So it is called the stopper. So what is the name of this connection? Hello, can you say what is the name of the connection? Dy how much? What connection you have made with this? What is name of this connection?
dy1.
dy1. So that's connection is dy1. Okay. So only with this type of ACB. So now here the phase sequence is AC. This is called the phase sequence. Now if we want to do similarly dy11, what should I do? Try to imagine. This is a complicated issue. Already dy1 is there. So now we will have to do the dy11. So then what should we do? It is a very complicated issue. Books also doing this because we have don't option. Uh, I don't know how to do this dy1. In books they are doing like this. There is no other option. So what they have done, you have to understand logically it's correct. So they have done like this. Okay? They have changed the D first. Okay? So here they have taken I don't know how they have taken, this is A, and then this is B, then this is C. Okay, and this line is A, this line is B, this line is C. Now again you can draw here. So this will be the A, this will be the B, this will be the. But here phase sequence is different. You know that phase sequence has been changed. It is A, B, C. Hello. So they have changed the phase sequence. Not only the phase sequence, you have to do the like this. Otherwise, you can't approach the dy11. So in a dy11, and dy1 is something different for drawing. It's very difficult. Okay. So that's the main problem with that. So this is a different issue. And in books they have represented like this DY11. So far we have discussed many connections. So whatever the connection we can write now. So DY11, DY1, YY0, YY6, DD0, DD6. So any confusion on this, again we have done DY11 and DY1. So many connection I have done. Okay. So you see that so many connections we have made. So in each case, whether it is, you see that here also you see that in delta y also, you see that in delta y it is a phase. So here it is a phase. So there is a 30-degree phase difference. So this is called 30-degree phase shift. So whether it is dy or yd, whatever it may be, whatever it may be, dy or y, yd, yd, there is 30-degree phase shift. There is 30-degree phase shift. Okay, phase shift. So that's the main problem with the connections, DD connections. So sometimes this phase shift is going repeatedly in different places. So that complicates the issue. That's why today our trends are that YY connection has been used for very high voltage. Okay, finally YY connection. That's very simple. And in YY connection, you will see that there is also, if there is a phase shift, then it is 6. That means 180-degree phase shift. That can be handled. But this 30-degree phase shift is becoming very dangerous. Okay. So that's becoming very dangerous. So what is the problem with the 30-degree phase shift? So problem with the 30-degree phase shift. There is a problem. Suppose a transformer T1, okay, T1, transformer 1, and T2, transformer 2. Now what will be the out of the transformer? Transformer is a box like this. So in a box, only you will have a HV side and you will have LV side. If it is a Y, then it will be the terminal 1, 2, 3. It will be A, B, C, and there will be a neutral. Okay. If it is LV, then it is a Y connection. Then will be this. If it is a delta, then only 3 terminal will be there. That is A, B, C. Okay. Similarly, here also another transformer is like this. You see that there is another transformer. Only outside a board is there. So HB side is like this. So A, B, C, and the neutral. So that's A, B, C, and the neutral. Already you know that. And the here D, it is also D, but it is a B and C. So suppose it is a delta, so it will be A, B, C. Now from the outside, can you determine whether it is Y, D, 11 or YD1? Can you determine it? Hello? From the outside, is it possible?
No,
To
sir. Without
identify?
any connection in the outside terminals, it is not possible to say which
So
one is.
that's the problem. It's not possible to identify whether it is a YD11 or YD1. So then you have to test it. Okay, similarly here also it's not a possible. So whether it is YD11 or YD1, so that's not feasible. So if these are not feasible, then can we do the parallel? So there is a problem in parallel. So you know what is the parallel condition. So paralleling of these transformers. So when you want to do the parallel of Q1 and T2, so problem is here. Problems are okay. First we know what is the meaning of the parallel. Parallel means what? Now you have to remember for parallel operation what we have to maintain. Hello. What we have to maintain. Suppose we want to do two transformers, single phase transformer. Single phase, as your laboratory is not going on, so that's why it has become a very problematic. Single phase transformers are to be uh, in parallel. So what is the condition you have to do? Hello.
স্যার
Suppose a
সিমিলার ফেজে থাকতে হবে।
no. Suppose a parallel means what you have to do. Suppose we represent a transformer T1 like this. Okay. Then another transformer is like this. I am not drawing very beautifully. Uh, that's not a. That is your task. Don't do like me in the answer script. You have to keep it very beautiful. Okay, because you will have a time. But here I have to teach. I have to make you understand, not the beautifully thing. Beautiful is the our dream. But here, if I want to do all these things very beautifully, then lots of time will be not wasted. Time will require. So I do not want to pay that time. So that's why I am doing in hurriedly. Don't take it as if that sir is doing so dirty way. Okay, don't consider like that. If I have a time, then I can do in better way also. But here I am doing for your understanding point of view. That's why I am not giving the attention for drawing very beautifully. But when you are doing in answer script, you have to do beautifully. That's my request. Okay, sir, you have done so. You will do repeat like that. So after your career, you have to everything you have to do neat and clean. Okay, presentation is very important. You know that. Actually, today world is depends on mainly presentation. Okay? Quality also important, but presentation is parallelly equally important. If you cannot present anything to the interviewer very beautifully, then their impression will be not so good. If you can do the presentation in a very good way, so whatever it may be, suppose you are doing something into the dustbin, so that also should be you should do a very proper way, okay, and very beautiful you have to do. So that's the beauty of the work. So everybody is will take care of that. So that's why I am giving you advice. Don't follow me, at least in terms of writing and the drawing. Okay? Try to understand only. So now, in case of the parallel, so what do you do? Suppose this is source, okay? Single phase source. Then primary can be parallel any problem, no problem. Suppose the source is here, so we can do here like this, and we can do like this. Is there any problem if we do the parallel in primary side? Hello. Is there any problem?
No, sir.
We connect two transformer T1, T2 as a primary T1 and T2 like this. Is there any problem? So as far as doing the parallel in primary connections, that's not a problem because each one is taking its magnetizing current individually. Okay. So they are not actually open circuited. So what does it mean basically? What is the from the equivalence and point of view? If we want to do the equivalent circuit, what does it mean basically? You know that this transformer will have a equivalent circuit like this. You know that this is the equivalent circuit of like this at no load. It will be for the T1. So a source will be here connected, no problem, same source. And similarly, for equivalent circuit of the T2 will be like this. You know what is this branch I have already described. So there will be like this. The same source you can connect, no problem. So this is a RC1, this is XM1. Similarly, this is RC2, this is XM. Is there any problem if we do the from the equivalent point of view the connections? Any problem in transformer? Hello. Hello. What is the problem if we do the connection? What should be the main basic here? You can say that the voltage rating should be same. Primary voltage rating should be same. Why? Tell me why primary voltage rating should be same. Hello. Because winding having the insulation, if the voltage exceeds, then the winding will be destroyed. Okay. So I think your time is going up. Okay. You have any class, any other class? Hello. Tell me. Then I will end it here.
No, sir.
Okay. So if you don't have class, then I will discuss this. So as far as the voltage rating, if you don't do maintain the voltage, suppose some 400 volt transformer primary, I cannot apply 800 volt or more than the 400 volt. Then there will be a insulation failure. Not suppose 400 transformer, I have applied 500 volt. Not necessarily RMS voltage, not necessarily immediately it will fail. But in the long run, a continuous stress, voltage stress will deteriorate the insulation quality and thereby a life of the transformer will be hampered. Suppose a transformer is rated for suppose the 15 years or 20 years or the 25 years, then its life will be decreased. So that's why you cannot use the voltage different. So voltage rating should be same. Otherwise, magnetizing current can be different because magnetizing current depends on kVA rating. So that should be kVA rating. Maybe it's a kVA 1. It's maybe kVA 2. You know, another rating of the transformer is the kilovolt ampere. So that may be different, but voltage ratio should be same. Voltage rating and the ratio should be same for both. Otherwise, you cannot do the parallel of the single phase transformer. And what is another thing you should do? Already I have told that in induced EMF there will be some polarity. Suppose in primary induced EMF polarity E1 is here. So and secondary induced EMF polarity is E2 is like this. Okay, uh, uh, not E2, no, T1 you can say T4. So it is T2 is like this. Now I don't know which terminal it is. So here polarity is like this. Okay, it is the secondary polarity, but here polarity is like this. So now you have to blindly, you cannot connect like this way. If we connect this way, what will happen? Suppose somebody has parallel like this. What will happen? Can you say that? Somebody has parallel secondary like this without understanding the polarity. Then what we should do? If you do the polarity or the parallel like this, then what will happen? Actually, parallel operation, then you have not studied. I think there is a problem in your side. You have not studied the parallel operation.
Sir, there would be a current flowing through the secondary windings.
So what is that current? So that's the important. So now, okay, current always will flow, but what is doing, what we are doing now, that's the, we have to draw by vectorically. Okay? So here is my pen. Okay, here is my pen. So now if we want to do the vectorically, so then it will be the E E2 of T1, okay? This will be E2 of T2, okay? You know that. Now, uh, a local loop has been formed. You see that. Now, this thing you should understand because most of the important part is the parallel operation. So, where is my pen? Sometimes I am missing my pen. Yes. Where is the local loop? So, a local loop. Where is my pen? Is there any pen? Here. My local loop is like this. So, a local loop, if you follow how the local loop is forming. The local loop is forming like this. So this is a local loop formation. So in this local loop, how the EMF are connected. Now if we want to find here local loop, you see that. Here in equivalent circuit, this is the R equivalent and X equivalent. Okay. Here also in equivalent circuit, you will have R equivalent, not exactly, it is 2, 0, 1, it will be X equivalent. Now we have connected, how we have connected? We have parallel. What is the problem now? What is the problem? Can you say what is the problem?
Circulating current will flow
Now you
in the
see that
secondary winding.
in terms of EMF, okay? What will be polarity of the induced EMF here? This in secondary. This is a part of secondary, okay? What is the induced EMF here? Usual one. Okay. Now in the loop, if you see that, so these two induced EMF and these two induced EMF are in series here. We can write it so that you can understand. The secondary EMF of T1 and T2 are in series with local loop. Okay, and into this local loop, so here drawing is has become some complicated, so we can avoid one drawing at least so that you can understand. So into the local loop, what are the impedance? And in local loop, local loop, Z equivalent 1 and Z equivalent 2 are the impedance, are in series, and the Z1 plus Z2 equivalent are very small. So huge current will be flowing into the local loop because the rated voltage are applied through this impedance. Okay, huge current will flow. Huge current will flow. Transformer will burn. So the huge current will flow to the primary because any current into the secondary, this can be acted as a short circuit. So as if short circuit is there, as if short circuit in secondary. Okay. So that is the problem. So main problem is that you have to, before paralleling, so another condition is that you have to assign the polarity of the induced EMF with respect to one transformer T1, T2. So always you have to do parallel with the similar polarity. Okay. So in secondary, to avoid this, to avoid this, okay, not avoid. Avoid is very that word. Right polarity to do right polarity. One have to check, have to test, not check. One have to checking is not a possible. One have to test the polarity test. Polarity test. So this is the main test, polarity test. So next day we will go for what is the polarity test. Anybody have any idea regarding polarity test? Today the class is going very lengthy. Already 1.5 hours is going on. Anybody have any idea regarding the polarity test?
Yes, sir. We have studied in diploma. We lateral entry students.
But those who are regular, they having no idea on that.
No, sir, we studied it in previous semester.
Okay. So then you have studied the polarity test. Polarity test, nothing is the a voltmeter will be applied. Suppose a can do it very simple, very simple. So polarity test. Okay, next day we will go for the polarity test, or you can do here also. So what are the important for parallel operation? Okay, I consider that you know that. So repetition, everywhere repetition will take it back on the course. So what are the then the another condition that uh, where is my pen? Pen is so losing my pen. So for the parallel operation, then uh, voltage ratio of the secondary should be same, primary to secondary. That means if the ratio is 1:2, then another transformer also should have 1:2. And the one voltage is primary voltage is rated, then the secondary voltage will be automatically rated. Another thing is that the right polarity connection should be applied into the secondary. This is the number two. Anything you know more than along with these two, any idea you can remember? Anything you require more for polarity paralleling? These are essential. Okay. These are essential to do the parallel operation. Number one, the voltage rating and the transformation ratio should be same. But the KVA rating need not to be same. That may be different. Uh, then any other condition? Do you know that any other condition to have the similar phase? Otherwise, there will be change of phases of the one transformer will give some different power factor than the other for the same load. The current taken by the transformer will be in different power factor. So that is another condition you have to remember that the ratio of the X by X equivalent by R equivalent should be same. Remembering it, not the magnitude should be same, their ratio should be same. Otherwise, there will be more complicated issue between the parallel of sharing. But these are not essential; these are required. So, so these three are the condition for the single phase transformer paralleling. Number one, the voltage. Number two, transformation ratio. Number three, the ratio between the X equivalent to R equivalent should be same to all. Okay. Uh, this is for single phase transformer. But what will be case for the three phase transformer? These three will remain. Along with that, another condition is required that is called vector group should be same. You know, so these three will remain, but along with that, the vector group also should be same. Otherwise, you can't do the parallel of the three-phase transformer. There will be a big issue if you can do that. Okay, so three-phase transformer. Okay, today after this, next day we'll go how to do the parallel operation. Now I want to print it. What is Microsoft XPS document? Do you have this?